Si pones el podio un poco más para atrás, te vas a salir un poco mejor, creo.
No estés lavado, ¿no?
¿Cómo?
Cuidado el vaso, cuidado el vaso.
Cuidado la cerveza.
Extrema gravedad.
Cuidado el MacBook.
Cuidado el cable.
Sí, no. Muy bien, ¿no?
Cuidado todo.
Stress level de la cara.
Quita el puto vaso.
Es perfecto.
Es un flight case o algo, ¿no?
Si ahí por adentro guardan como un biombo con el colegio.
Totally different. It's like
Cuidado que, bueno, sale y
all
no
from
sale.
the people. It's not different. Uwaga.
Baja.
Hi
Uwaga.
guys, my name is Victor Castell, for the ones who don't know me. I am I'm CTO at Season, where we provide solutions to our clients. And today we are gonna talk about Go language. But first of all, I want to know, let me know something. How many of you have heard about Go?
Only head.
Only heard about Go? Something?
Not about the game.
Okay. How many of you have read the documentation or seen the website? Raise hands. Okay. And how many of you actually have written some of Go code or played with Go? Nobody. Yeah.
Useful code?
No.
Not the top 5.
Any code, don't mind. Okay, good, very good. Well, first of all, let's begin with a little of story that led to the Go creation. Who made this language? Well, Rob Pike from the Unix team, Plan 9 and Limbo language. Ken Thompson, Unix, he worked at Unix, Plan 9, B and C programming languages, Rascorps, Plan 9, Google Code Search, regular expressions, Robert Grismer, Google's V8 JavaScript engine, Java Hotspot VM, plus great programmers like Brad Fitzpatrick, the guy who made Memcached, Andrew Gerran, Stephen Marr, and many contributors from the open source community like Blake Miserani from Heroku. This is an outline of the talk. We talk about these topics. First topic, a long journey, precedents. There were the C language and Unix are widely used. There was a need for a high-level programming language in the Unix platform. Then Simula-style object-oriented programming was implemented on top of C, and then we get C++. C++ is a superset of C, so it's not a very good fit for the language. C++ became popular in the industry and research. Then Java was born as an industry response to for an easy C++, because C++, all we know, it's a little bit complicated, huge, and difficult to learn. So the universities and schools choose Java as a standard teaching language. I'm sure almost everyone here have done Java at school. Consequences of this is C++ and Java are hard to use. They are verbose, difficult to read, and well, if you don't use an IDE, it's it's crazy to program with these languages without an IDE. To address these difficulties, we need patterns for programming, and Peter Norvig, Director of Research at Google, so his personality, said patterns are a demonstration of weakness in a language. But these languages are vital and quite used nowadays for all types of big systems. As a reaction, well, these facts led to a reaction from different communities, open source communities, that were worried about developer experience. So they want to make easy languages for the people to learn. Languages like Python, Ruby, Lua, JavaScript, Erlang emerged in part of this rejection of the standard languages, C++ and Java, and other beautiful and super well designed languages also arisen. Scala, Haskell, this type of languages. Other approaches are in languages invented. They call it outsider languages. We are living a golden era of language invention as a response to the standard model. CoffeeScripts and hundreds of languages are invented. I think almost every day. Why this popularity in these outsider languages? Most outsider languages like Ruby, Python, JavaScript are interpreted and dynamically typed, and the standard languages, Java and C++, are statically typed. Non-expert programmers have confused easy of use with interpreted and dynamic. This is not true. This confusion is the product of trying to implement a paradigm onto a language, C++, in this case over C, onto C, that doesn't support object-oriented cleaning. Filling the gaps with, with Go, they are trying to fill a gap. Standard languages are efficient, performant, and safe because of this kind of typing. Are very powerful in expert hands, although they are too big and huge, but they are very powerful. Really big systems are built on them. Adapts well to corporate environments, lots of coders, big systems being programmed every day with these languages. Standard languages are not developer friendly. They are hard to use. The compilers are slow and clumsy, and binaries are huge. Many programmers prefer to not use this kind of languages. They are old and not very well suited to multi-core network development. It's not its primary target in the years when they were invented. There were not multi-core and all these networks we have today. JVM, for example, have limits in memory management because of its naturality, because of how it's implemented, and have limits in memory management, and it already found its bounds. Ruby and modern languages became popular in part because they don't have the mentioned downsides. They don't have the bad. They have less keystrokes because of dynamic typing, no curly braces, no a lot of things. Clearly, you don't need an IDE to program with dynamic languages, most of them. No compile time, they are interpreted, so you write, then run, and it's going. But they also have some bad things. They are slow because of interpreted, not type safe, static errors occurs at runtime, we all know this. Doesn't scale well. Ruby doesn't scale. Yeah, this is true. And they are not. They are also not very modern. They were invented some years ago. We are talking about Go, that it's a recent language, so they are not very modern. In fact, the gap. We need a new language that has the good, what's the bad. and is suitable for modern computing infrastructure. It's statically typed with fast execution time and fast compilers, light and easy to write, fast to work, scales very well, doesn't require tools, but you don't require an IDE to program with Go, but supports them well because it gives IDEs support to read the tree, the language structure and types, and it's good at networking and multiprocessing. Well, a bit of code of Go. What is Go? Go is a language that is fun to work with, efficient and open source. It's true open source. It's developed at Google, but they are open to contributors outside from Google. The core language is developed mainly. The core team, the core team is all hired by Google, but there are contributors from many countries. Go is statically typed and compiled like C++ or Java with no VM, but in many ways feels as lightweight and dynamic as JavaScript or Ruby. This is the great point. It's designed for modern computing. Multicore is at language core. It's a command from the language, so you don't have to worry about this tasks. It's aimed at software such as web servers, but tend to be a very great language for general purpose programming. So it can do any type of system and application. It's developed at Google, and this is how a web server looks in Go. Not too much lines of code, actually 14. And if you want, we can see how this runs. It's as easy as trying this. Start a new file, you have an IDE. To work with this, you can see it's very light code. There are with the compiler, when you download the compiler or the SDK of Go, you get a nice Go command with that can do a lot of things, and one of these things is run programs from the command line with just one command. It compiles, links, and runs the command. It's as easy as pie. Hello nothing, because we have parameter here. A web server running Go. And nothing here. Okay. Well, you can see here it's a package definition. 3 imports from ifmt. It's a package for string formatting. Net HTTP is the HTTP server implementation, and the log library. This looks a bit weird at the beginning, but if you pay attention, you can see that it's very easy code. You call the package HTTP. It's called with the last word from the package path. You call the package and call the function that registers a path, and pass it a function that handles the request. You have 2 parameters from the input, and then you print will print hello and the parameter that gets in the first part of the path. This instruction here are logging a fatal error if it occurs. Not in this case, but then launch listen and serve in the selected port for the server. Nothing more.
So you don't declare the type of result of function?
You in which case?
Mine.
No,
It's not
no, the function main is how you begin a program in Go, and it doesn't have return type. You don't have to declare it because it has to be this signature. Just func main and brace. Is this form? This is the main.
The function that handles the root URL, does it define the return type?
No,
No.
it's just a function.
Yeah.
The type is function.
So
No, but I mean like the return type. What is the returns? You don't define it.
does it explicitly
In this-
return the last line of the code, like
this
for example
function?
Ruby, or
No, the handle funcs.
The
I mean, it's not.
What if you want to return something here? How do you declare what type it is? What you're returning?
Maybe the next example, no?
Sorry, first
I
one by
like-
one.
my question is,
Yeah.
we have this function, right?
Yeah.
And it doesn't return anything.
No, it just
Well,
it returns itself.
Okay.
It's a function.
Okay.
Yeah.
It looks like no. Oh, God.
Yes, it's look like a lot like no. It supports. In fact, Go supports very well functional programming.
it's in Ruby?
And you were asking. Correct.
I mean, what if you want to return something here? I mean, do you need to declare which type of
Yeah.
which type are you returning?
You need if you want if you have to make a function that returns something, you have to declare its type.
So if you don't put anything there, it's void, and if you put something, it's
It's this
integer
type.
or whatever.
Yeah. Highlights of the language, as you can see, it's a very light language. We have multiple return values, like you have to declare the type. It's in this case and string. We return one and okay as a string in the function foo. Name it return parameters. You have the function foo. And one named input parameters that it's bar. We can say without name or with name. No? In this case, that returns bar. You make a calculation inside a function of anything and return implicitly returns the name parameter. It knows that it has to return the bar variable inside the function. Have variable input parameters that it's variable length input parameters. We can have function, greeting, prefix, string, comma, who we mark with this notation dot 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 and the type of the input parameters, and you can pass a string, comma, and then any amount of input parameters you want, and then this variable who will have the value as a string array with this name. You can work with these values inside function. More highlights. Support very well functional programming style. Those supports first-class function, high-order functions, user-defined function types, function literals, and closures. Closures, for example, are just local functions. You declare an input parameter that is a type of function. This is the same like the web server we were seeing before, that gets a function as an input parameter. So listen and serve, or handle request, was waiting for a function. Then you can execute this function inside your function and get the value it returns, and then just execute a function immediately is a closure that can access the local variables. It's a lot of JavaScript. Looks like a lot of JavaScript.
Excuse me, can I ask one question? Because here you say that what you want to pass.
Okay, I have to maybe clarify a point is that maybe the type declaration it's a bit weird because it's the name of our variable and type. It's this order. It's
Okay, so
maybe
name of the type is fun with these brackets. These brackets are.
yeah, because it's a
part of the
function,
name.
it has to have the brackets. Yeah, it's a bit different from other languages where you put the type before the variable name. And in this case, with Go is just algorithm.
Yeah,
So if you
The other way.
pass a function, you have to put the brackets there.
Yeah, that's how you declare a function type, right?
Yep, this is a function. This is how you declare a function type. It's a function type import variable.
So probably if you have an example with like an array, you would declare you're receiving an array of strings or array of functions or whatever, right?
An array of functions, you mean you can, yeah, you can do a map or, yeah,
So you could pass several functions, right?
yeah.
Okay.
Yeah, it's not, maybe it's not very useful this way, but you can do, it has very advanced data structures that you can use, for example, to pass a map, and a map is a hash map, and you can assign a string key for each function, for example, and pass a string and function string and function string. So you can search them in the hash map to work in the inside.
So arrays are hashes as well.
No, arrays are one thing, hashes or maps are another thing that it's available too. More
Okay.
features.
One question, can you mix the array values, for example? Can it be an integer function or has it to be the same type
In a hash map, for example, no?
in any list or collection of two?
Can you have an array with integers, strings, functions, and random
Yeah,
stuff?
yeah, you can have an array with different types of variables. Yeah, you don't have to declare the type that is going to be stored in that array or hash map.
So but if you
mix it.
declare type for array, it has to be the same type then, I guess.
Sorry?
If you declare
Yeah.
this is an array
Yeah.
which has integer values,
Yeah.
then you can't mix it up. It has to be an integer value. Every item has to be an integer value, I guess.
This is an array of functions.
For example,
Yeah, it's an
And it's
array.
only functions, not
Yeah.
strings.
No, sorry. You can mix it in types in. No, sorry. I missed. I am in a mistake. No, you declare the types that you are storing in an array or in a map, and this is fixed. Yeah, because it's statically typed.
Makes sense.
Yeah. Sorry, I'm mixing
Yeah.
concepts here. Sorry. More features. Type inference. This is why it's very light in syntax and very easy to program because you don't have to declare the type of a variable when you are assigning a value. When you use this notation with the 2 points, you can assign a value to a variable and it gets this type. It's implicit this type inference. Interfaces, you can declare interfaces that are simply a set of methods and are satisfied implicitly. Every type that implements its methods is satisfying implicitly the interface. This is very powerful because you can declare types. You can have libraries of anything that declare interfaces, and you don't have to touch these libraries to, or simply you don't have to declare that you are implementing that interface. If your type implements the methods of the interface, it is satisfying implicitly the interface. So you can satisfy any number of interfaces in your type at the same time. Just for multiple inheritance, but there are no concept of inheritance here.
About the interfaces, do you know how it deals when you have several interfaces that define the same method? How does it handle clashes?
There are several interfaces that has the same
Like you have
name.
a full interface that defines this private method, and then you have another interface that defines the same method with that name.
I don't know how to answer your question.
Okay, you have
I don't know.
Damn it, I just have to learn this now.
Maybe it throws a compiling error. Maybe it's you cannot do this. We can try it later. Concurrency basics. You launch a new process, a new thread with Go routine in this case, with the keyword Go and calling the function. This starts a Go routine that is a Go routine is a thread that is light than a real thread. You can have a lot of Go routines in multiplexed in one thread of the code of the machine. So you don't have to worry about the amount you can fire a lot of Go routines and it works well. Channels are used for communication between Go routines and are receivers and emitters that can receive a value or emit in like in this example. You have to declare a channel, then launch a Go keyword that serves anything, and then the execution flow when you fire this starts a new thread, and the execution flow immediately goes to the return and returns this channel that you can use for listen to events inside this thread. You can wait for events, or you can.
There's any way to scale Go routines? I mean, you mentioned that they were like threads.
Yeah.
Can you
No,
scale
they
them,
are
or?
not like threads.
Okay.
They are like them.
So lighter threads.
Yeah.
But
it's like
you
the
can
threads.
yield from a Go routine or something like that, like in Java threads. Or?
What do you mean? Yield?
I mean, yeah, yield the control of the CPU until someone tells you to resume execution.
Yeah, you can sleep the execution flow and it stops from doing things, and when it's ready, it can end or returns a value to a channel, so someone is listening and continue the execution.
Do Go routines to the shared memory?
No.
No?
No.
They don't have access to the variables outside.
No, this is why it's safe. This is why it's safe. You have to go always through the channels,
Okay.
because they don't share memory. They don't have
The problems that
the problems that
synchronizing the threads and
this stuff. Yeah, this is very safe to do concurrent programming with Go. Dependency management in Go. It's managed by the import keyword, and it's expressed in the source code. There were a lot of discussion in this type of dependency management in the code team, but they decided that this was a very good way to implement dependency. It serves two purposes. It's an import path in the local file system and URL to an external repository. This only in the case of external dependencies, not the core lib, the standard lib. Works very well, this system. You push your code, you create a new Go library, you push your code to a public repository, and poof, there are a new Go library out there. And the go get command, all commands with Go, more or less Go commands, begin with the Go command, and the get instruction, download and install all the dependencies in a package in the library. It's easy to define and easy to use.
How do you define? Can you have control over, like, yeah, I want to use this import, but a particular version or something?
Well, this is a very very discussed topic in the Go mailing list, and no, you can specify a version of the library. You can specify with branches which Go runtime target your library or versions of your library. For example, you can have 60.1 branch, and the go get command knows that it has to, if you are running this version of the runtime, this go get command gets the library, that the branch that corresponds to your runtime, but not the version of the library. So you have to have green master always, and not do APIs hard changes in your library. You can create another repository like path2.
And what about this library is not cached in any way. When I do this import and put some URL, it's not. I have to be online to go with the Go. Like a bundle.
Yeah,
Okay.
it's like a bundle. It downloads the library and stores it in your local path with this path. GitHub.com is another path. It's the path that gets stored to your file system, and if you distribute your local file system, your local package, with all this code, it doesn't re-download the thing again.
What if path has other dependencies?
It downloads also.
Cool.
Yeah, it's recursive and it gets downloading dependencies.
Which source version control systems does it support?
It's Bazaar, Mercurial, Git, Subversion, more or less. Yeah, it's more or less. It's the more popular CDS. Yeah. You can read. Other features. Emphasis on simplicity. They want to build a language that is very simple, easy to learn. It's garbage collected. You don't have to worry about memory management and these kind of things. It's like a C, because you can lay out your variables in memory with structs and types very in detail, but it's garbage collected. It has a consistent standard library, very well documented and very complete. It has integrated testing with a Go command too. You can go issue Go test, and it begins to test with a structure. You have to naming with a naming convention. If you use certain names for your files and your functions, it runs tests in it. It's very fast compiler, very fast. It can be used as scripting languages. You have seen. I've seen in the Go server demo. It's running here, running again. It's very fast. Targets i386, 64 and ARM for mobile development. It has a compiler that are targeting, or more or less it's not finished, but they are targeting Darwin ARM, so you can build app APIs for IOs. But as in respective languages, it also has grammars like the one we talked about, the versions.
Excuse me, how can it be used as scripting language?
What?
Because you said that it can be used as scripting language. So how to do it?
No, as a script, I mean, yeah, I mean, if it was, it's like, it behaves like,
But the compiler is very fast. And
yeah,
it's
the
safe and
compiler is
fast.
very fast, and it's, you have the, well, you actually, you can use it. You can hashbang, go run in a scripting file, and it gets compiled and run with just in the file. So it gives the feeling of scripting languages. It's not really scripting. Right, present. Go 1 released this month, last month, 28 March. We have Go 1 release out there, so it's a stable, mature, and suitable for real world developments. It has easy installation. You can find binaries for OS X, Linux, and Windows in the web of the language, golang.org. It's used in production at big companies, Google, Heroku, etc. It has very high community, and it's growing very, very fast, plus 100 messages a day in the list. It's crazy to receive half a digest, of course. Erlang versus Scala versus Go. It's not a versus really, but it's a comparison of concurrency model. Erlang and Scala implements the actor model, and Go implements Go routines, is the way it implements concurrency. Scala has thread-based actors that are heavyweight. Each one requires some amount of memory, but it has another library that implements lightweight actors. But there are one library that uses one thread per actor, so you can die soon. Go routines are lightweight and threads are heavy. All the three models uses the same mechanism for messaging interchange. It's a channels based mechanism, and all three avoid the problems of complexity associated with concurrent programming we were talking about. Erlang has write-once variables. Correct me if I make a mistake here, because I'm touching things that I don't know very well, but I think Erlang you can declare a variable and assign a value, and you can reassign a new value to this variable. In Scala, passing around primitive data in channels like integers is expensive because of some type of JVM legacy I don't know very well, but I read it somewhere. So, and the comparison. Node.js, JavaScript doesn't have concurrency features in the language natively, but it could be compared as a server programming platform, as you saw before. Node standard lib is awesome, but it's not enough for doing real work. You need a lot of standard libraries for doing sites in its complete form. You need templating, you need SQL or Mongo or etc. Go standard library is really awesome. It has HTTP for managing servers, templates, WebSockets, target management, JSON, XML, SQL, and SMTP. So it's a very, very, very complete library that you can trust because it's a standard library in the language. When you download the Go SDK, it comes with all of these nice features inside. Node code is by definition non-blocking and asynchronous. This is true, and Go lets you write synchronous looking code. This is what is the feature that, or the characteristic I love more from Go, that lets you write synchronous looking code which behaves like if it is asynchronous, without requiring you to handle the callback spaghetti. You are not forced to, you can do callbacks if you want, but you can write normal Go code, issuing Go commands, and you get non-blocking I/O. Many libraries in the stdlib add on non-blocking, so the server library is non-blocking by design. So you can, the web server you saw before doesn't have the C1000K, C10K problem. You know the problem that blocks the server in more than 10,000 records. That nodes address very well, Go is addressing it very well too. Well, it's a game because it's not representative of anything, okay? But you know the infamous post, Node.js is cancelled. I'm sure you read it. This is the Fibonacci sequence showed in the post. Well, I wanted to show it here to do a comparison, an example. No, this is the same code for the Fibonacci sequence. It's a function. It's very similar. It's a little bit more large because of spaces and trailing and braces and all these things, but in fact it's very similar. Basically, it's space.
Okay.
Show me the numbers. Yeah, I know. You want to see the numbers. Node run this in 3.379 seconds. Okay. No, runs this in 1. Not bad number. Projects using Go. Well, we have some big companies using it. Heroku published this high available data store. They are using inside Heroku to store, I think, server configuration and this type of things. When a server fires up, it gets the config from there or something. I don't know very well. But it's a great project. It's available on GitHub and it's open source. StatsHat is a new startup based in somewhere of US that built some kind of application like dashboard type, something dashboards we were seeing the other day here, with where you have an API and you send information and you get nice graphs. It's all developed in Go and beautiful stuff, as you can see. Njimoku published Falcor. It's a modular HTTP web server framework. Go standardly already has a HTTP framework, but this implements some kind of rack on top of Go standard library for you to put modules in a request flow and get features like logging or redirecting and e-tags and all kinds of things. It's an open source project too, and you can get it at GitHub too. MoveWeb is it's a startup too. It's a company that develops system to bring your website, your traditional website. You design and you build your website for the desktop size, and they convert you to the mobile form in real time, more or less, with some kind of JavaScript tricks or something. They don't have any open source project, but they are growing very fast, and they are a lot of people. They are investing a lot in Go. They want this language to go forward. try it. I recommend you if you like what you saw, try it at golang.org. There are full source code, documentation, and a playground in the browser that you can try a bit of Go code there in real time. So references. That's it. Questions? More questions?
Are you using it for something in production?
Yes, yeah, I've been playing with it for 6 months, more or less, from now, and the beginning was very slow and just toying and hacking something. But we have some kind of web services or little applications for our clients in production that are running every day, and they are managed by Upstart in Ubuntu, and they are up running quite well.
And when you did this application with Go, did you choose it because you wanted to play with Go, or
Yeah.
you saw some advantage? You're trying to do something with local concurrency?
No, it's not for real necessity for concurrency, but it's more like toying and using it for production. Why not? Let's try it, and it runs well. Questions?